All right, let's talk about something that really separates the Python hobbyists from the pros. If you're looking to do anything serious with Python, and I mean anything beyond a tiny one-off script, then you absolutely have to master this. We're diving into virtual environments. And trust me, this isn't just a suggestion, it's the professional standard. So let's get right into it.
And seriously, when I say non-negotiable, I am not exaggerating. This isn't some, oh, that's a nice little trick to know. No way. This is the baseline. It's what recruiters look for. It's what senior developers just expect you to know. When you get this, you're sending a clear signal that you're ready for real-world projects, that you can actually work on a team without causing chaos. It is that important.
So you might be wondering, okay, but why all the fuss? What's the big problem? Well, let me paint you a picture, a classic scenario that pretty much every developer runs into. Imagine you're juggling two different projects, right? Project A needs a specific, maybe older version of a library, let's say requests. But Project B, the shiny new thing you're working on, needs the latest and greatest version of that exact same library. If you just install them normally on your computer, what happens? Whichever one you install last wins. It just overwrites the other one, and boom, you've got a massive, frustrating conflict, and one of your projects is now broken.
Yeah, that situation right there, it has a name, the dependency dilemma. And it's the perfect example of why just installing everything globally, onto your main system is a recipe for absolute chaos. It's a ticking time bomb for your projects. But hey, don't sweat it, because there is a really elegant, clean, and professional way to solve this whole mess. And that solution is the virtual environment, or venv, as you'll hear it called. The best way to think about it is like a clean, isolated little bubble for each of your projects. It's like giving each project its own private sandbox to play in. Inside that bubble, you can install whatever you want, any package, any version, go crazy. And the beautiful part is it won't touch or even know about anything happening outside of its little world.
So you see how this just solves everything? It hits all the pain points we just talked about. You can install packages for just one project. You can have different versions of the same package for different projects. No more conflicts. And here's the real kicker, especially for teamwork. It makes your project totally reproducible. Anyone, anywhere, can set up the exact same environment you have. That is a game changer.
Okay, so creating these isolated bubbles for our code sounds kind of like magic, right? But it's not. So how does it actually work? What's really going on under the hood?
The secret sauce here is actually pretty straightforward. It's a three-step trick. First, when you create a venv, it makes a little copy of your Python interpreter and sticks it right inside your project folder. Second, it creates a brand new, totally empty site packages folder. This is where all your project's special libraries will live. And third, this is the clever part, when you activate it, it plays a little trick on your command line. It temporarily changes your system's path to say, hey, for now, when you type Python or pip, use the ones in this folder first. It completely bypasses your system-wide stuff.
All right, enough theory. Theory is great, but the best way to really get this is to get your hands dirty. So let's stop talking about the what and why and actually dive into the how. We're going to create our very first virtual environment, step by step.
So pop open your terminal. First things first, we need a project folder. So make a new directory, call it whatever you want, my project is fine, and then cd right into it. Now, for the magic command, you just type python-m venv ven. And let's break that down real quick. You're telling Python to run its built-in module, venv, and that last venv is just what we're naming the folder it creates. It's a common convention, makes things easy to find.
Great, the folder is there, but just creating it doesn't do anything yet. You have to turn it on. You have to activate it. Now the command here is a little different depending on if you're on Windows or a Mac/Linux machine, but the idea is exactly the same. For all you Windows folks, you'll point to the activate script. For my Mac and Linux users, you'll use the source command.
And how do you know you did it right? You'll see it immediately. Look at your command prompt. Right before your usual blinking cursor, you'll see this little prefix, venv. That's it. That's your signal. That tells you the isolation is on, the bubble is active, and you are now working inside your own private little Python world.
Now you can just use pip like you always do. Go ahead, pip install requests or whatever you need. But here's the cool part. That package isn't going onto your main system anymore. It's being installed directly into that local ven folder. You can even check by typing pip list. You'll see it's probably the only thing in there. And when you're all done for the day, just type deactivate. The little prefix disappears and you're back to your normal system. The bubble is off. Simple as that.
Okay, so you've got the basics down. You can create, activate, and use a virtual environment. Awesome, but that's really just level 1. To be a pro, you need to know how this fits into a real-world workflow, especially when you need to share your project with others. This is where the real secret weapon of professional Python development comes in. It's a simple, humble text file called requirements.txt. Now, don't let its simplicity fool you. This file is everything. It's the blueprint, the recipe, the DNA of your project's environment. It lists every single package your project depends on, down to the exact version number.
And the workflow is just beautiful in its simplicity. It's a two-step dance. Step 1. Once you've installed everything your project needs, you run one command, pip freeze, to capture that perfect list and save it to your requirements.txt file. Step 2. When your teammate gets the project, they just create their own venv and run pip install-r requirements.txt. And like magic, pip reads that file and installs the exact same set of packages. Perfect replication every single time.
So let's lay out the rules of the road. These are the non-negotiable best practices. Rule 1. New project, new venv. Always. No exceptions. Rule 2. The venv folder itself, that never ever gets committed to Git. It's huge and specific to your machine, so you add it to your .gitignore file immediately. And Rule 3, the requirements.txt file, you always commit that.
And just as important are the rookie mistakes to avoid. They're basically the exact opposite of what we just covered. The biggest one, the one everyone does at least once, is forgetting to activate your venv before you start installing stuff. You get excited, you type pip install, and whoops, you just installed it globally, completely defeating the purpose.
Now, this might all seem like just tidy project organization. And yeah, it is. But it is so much more than that. Mastering this workflow isn't just about clean code. It's about leveling up your career. This directly affects how seriously you're taken in the job market. Because, think about it. When you can talk confidently about virtual environments, you're not just showing a technical skill. You're demonstrating that you understand core professional concepts like isolation, reproducibility, and the workflows needed to prevent disasters when code gets deployed. You're speaking the language of production-ready software.
So picture this. You're in a technical interview. I can almost guarantee you're going to get a question that sounds a lot like this. They're not just testing your memory. They're trying to figure out if you've actually built things and faced these real-world problems. So, what's the perfect answer?
You want to build your answer around these 4 keywords. Talk about using venv to create isolated environments. Mention requirements.txt as the way you define and recreate dependencies. And then you drop the 2 magic words that show you get the big picture. Isolation to prevent conflicts, and reproducibility to make sure the project works for everyone, everywhere. That is a home run answer.
So let's put it all together. This is the full A to Z professional workflow. This is what you do the first time you work on any new project. Step 1, you clone the code from the repository. Step 2, you move into that new folder. 3, you create your Vim. 4, you activate it. 5, the crucial step, you install all the dependencies from that requirements.txt file. And only then, once your environment is a perfect clone, do you finally run the code. That sequence is the universal industry standard.
So there you have it. We've covered the what, the why, and the how. You now have the playbook for the full professional workflow. But I want to leave you with one final thought to chew on. We know it solves problems on our own laptops, right? But think bigger. What is the absolute, single most important reason that a project's dependencies have to be perfectly isolated and defined for that project to have any chance of success out there in the real world?